Evaluate the function below at the indicated values. S of t is equal to the square root of t plus 7. In part A, we're asked to find s of negative 7. So we write s of, using our formula, wherever there's a t, just leave think of the t as a placeholder. That's where we're going to put the input. So we have s of the input is equal to the square root of the input plus 7. For s of negative 7 is the input. So we'll put negative 7 in each of the different parentheses. So negative 7, that is our t value. So wherever there's a t in the formula, we're replacing it with the number negative 7. Now evaluate. Negative 7 plus 7 is 0, so we get the square root of 0. And 0 times 0 is 0, so the square root of 0 is 0. So s of negative 7 is equal to 0. In part B, we're asked to find s of 2. So again, we write s of, wherever there's a t in the formula, use a set of parentheses. And then put the input in the set of parentheses. So if we want to find in part B s of 2, we put the number 2 in each set of parentheses and then evaluate. 2 plus 7 is 9. And the square of 3 is 9, so the square root of 9 is the number 3. So s of 2 is equal to the number 3. And finally, for part C, we're asked to find the domain of the function. So we have to recall the definition of domain. The domain is the set of valid inputs. So far, we've seen that negative 7 and 2 are valid inputs. When we inputted negative 7, we got an output of 0. When we inputted 2, we got an output of 3. A number is not in the domain if it does not produce an output. So to illustrate this, let's use our calculator. On the calculator, for s of t, we'll use y, and for the t, we'll use x. So on the calculator, we'll investigate y is equal to the square root of x plus 7. So first of all, go to y equals and enter the formula y is equal to the square root of x plus 7. Once you've entered the equation in the calculator, produce a table of values by first of all setting up the table. Go to second window to set up the table. What I generally like to do is to explore negative numbers, 0, and positive numbers. So put the table start on -10 and then increment by 1. So change table start to -10 and then increment by 1. Once the table is set up, view the table by going to second graph, which is table. Now notice in the table that when x is -10, the calculator produces an error message. This error message indicates that -10 is not a valid input. We also get an error when x is -9, so -9 is not a valid input. -8 is not a valid input. The first valid input that we encounter is -7. When we input -7 into the function, the output is 0, and so -7 is a valid input. We see that the valid inputs start at -7 and are greater than -7. Let's take a look at a graph to see how the graph corresponds to this as well. We'll want a good viewing window. To get a good viewing window, let's go to Zoom and select Zoom Standard. Zoom Standard. Notice that the graph starts over on the left at -7 and then continues on to the right. So that indicates that the domain, the first number in the domain, is at -7, and then the graph continues over to the right. If we hit trace and type in -7 for x, we can see that when x is -7, the y value is 0. If we go just to the left of -7, then no output value is created. So any number to the left of -7 or any number less than -7 is not a valid input and is therefore not in the domain. Now the way that we can determine the domain from our formula is to remember that the square root of a negative number is not a real number. We need to make sure that the radicand is not negative in order for the function to produce an output. So we want to make sure that the radicand, x plus 7, is greater than or equal to 0. The radicand cannot be negative. So let me just highlight the radicand. The radicand is the part underneath of the radical symbol. The radicand cannot be negative So the radicand is x plus 7. If it cannot be negative, then it must be non-negative. And if something is non-negative, then it is greater than or equal to 0. In order to isolate x, we can subtract 7 from both sides, and we get x is greater than or equal to -7. And that's consistent with what we saw in both the table and the graph. So what is the domain of the function? It says write using inequality notation. The inequality is x is greater than or equal to -7.